Assalamualaikum and good day. I bid to my UTP supervisor, Dr. Chua Chonyang, and also UTP internal examiner. Alright, so before I start my presentation today, I'll be introduce myself first. My name is Nur Ainena Elisza, Binti Zekmil Virgo Khasodgi, with ID 18000082, and I'm a chemical engineering student currently in my final year first semester. And for this semester, I'll be taking final year project 1, and the title for my FYP project is Mathematical Development of Breakthrough Curves for the Investigation of Multi-Component Gas Adsorption. Right, so my presentation today, there will be 7 parts of them, which is introduction, problem statement, objectives and scope of study, literature review, proposed methodology, way forward, and last but not least is the reference. Alright, so let's look at for the first part, which is the introduction. Alright, so for the first part, I'll be explaining about the introduction of this project, which in gas separation, there are a few types of ways to separate the gases, which are cryogenic distillation, liquefaction, and also adsorption. Alright, so let me explain them one by one. For the first one is the cryogenic distillation. So it is a process of the gas mixture where it will be cooled down, where the components will reach the low boiling points and undergo the distillation at low temperature. So by using this method, it would be able to produce a high purity of SF6, which is the sulfur hexafluoride, which is also known as ultra-pure, and also usually applicable in semiconductor industries. Alright, so for the second method, which is liquefaction. Alright, so what is liquefaction? So liquefaction is a process where the component would undergo a phase change from the gas phase to the liquid phase. Alright, so which this method could save up volume up to 4.5 times smaller in liquid phase, which is suitable for far distance of the resources and also the processing plant. Right. So for the third method, which is the adsorption. So adsorption is a process where the component will be adsorbed by using the solid adsorbent in the packed bed reactor, which this method requires no changing of phase for the separation of the components, which contributes to the energy efficiency. So among these methods, adsorption has been selected as the best method of gas separation, as it is energy efficient and also has lower energy quality. And as we have narrowed down our focus to the adsorption, so many studies has been conducted about the component in the equilibrium condition, where it only measures single component, and that condition is one of the limitation where in real cases it is not possible to calculate or to simulate only one single component that exists at one time. So as we can see from figure 1, suggests the quantity adsorbed for a single component, which is a carbon dioxide and nitrogen gas. When we measure them individually, it will not reflect the real cases, and that is why we need to study for breakthrough simulation. Alright. So for the second part, which is our problems. Right. So many studies have been conducted, right, about the carbon dioxide. So the carbon dioxide capture has been extensively studied as the carbon dioxide involved in every process. Alright. So since there are many articles or papers that have been conducted as of the usage of carbon dioxide, so we have seen the gap where less research are covering the SF6 compared to the carbon dioxide measurement under the real condition. Alright, so and also we can see that under real condition it is difficult to conduct the experimentally. Alright, so which most studies only covers about the ideal condition, which is the single gas, which not reflecting the real condition. Alright, so that is why the measurement under real condition are difficult to conduct experimentally, and that is why the proposed solution for this project is to develop the mathematical development through the breakthrough curve. Alright, so the next part is the objectives and also the scope of study. So the objectives are to develop the mathematical development of binary components of the gas adsorption breakthrough curves, and also to verify the breakthrough curves developed from the previous studies. Alright, So that is why our scope of study is about the mathematical development of the breakthrough curves and also the simulation of the using MATLAB. Alright. So let's look at for the next part, which is the literature review. Alright. So for this part, as we have mentioned before, we have choose the gas separation uh, as adsorption, alright, which is as the best gas separation method. Right, so as this process takes place in the packed bed reactor, so we need to choose the suitable adsorbent to be used. Right, so the adsorbents are zeolite and also the activated carbon. So as from figure 2, zeolite has the pore size of 0.49 to 0.51 nanometer, which is relatively close to the kinetic diameter of the SF6, which are 0.51. Alright, so for AC in the figure 3, we can see that the pore size of AC is around 1.1 nanometer, which is much more bigger than the zeolite, and this is one of the factors why zeolite is chosen as its adsorbent for this project. Alright, so move on for the next figures, the fourth and the fifth point. Alright, for the carbon dioxide and also SF6. Alright, so actually both of them are greenhouse gases, and due to the increasing number of the anthropogenic activities, it contributes to the global warming and also climate change. Right, so the global warming potential of SF6 is around 23,900 to 1, which 23,900 is the impact or the potential of SF6 as the standard compared to carbon dioxide, which is 1. Right? So this figure tells us that the release of SF6 to the environment could give more impact of 23,900, much more bigger compared to the carbon dioxide release. Right? Not only that, SF6 also has longer atmospheric lifetime, which it could stay much longer in the atmosphere. But more studies of carbon dioxide have been conducted, while SF6 impacts are much more severe compared to the CO2. Alright, so due to the less research of SF6 adsorption, so that is why we are simulating the breakthrough curves to study the adsorption of SF6. Alright, so from these curves, we can get the selectivity and also the gas adsorption capacity. Alright, so as we all know that gas adsorption capacity is much more lower than the isotherm, because the adsorption capacity measured during the breakthrough curves typically demonstrate lower capacity compared to the equilibrium condition. Alright, so move on for the second part of the literature review, which these findings. Alright, these findings are the main findings from the article that are contribute to this FYP project. Alright, so which mentioned before, zeolite as the potential adsorbents for the SF6 adsorption, and the same adsorbent also could absorb the carbon dioxide better than magnesium for the carbon dioxide and nitrogen adsorption. Alright, so these findings are crucial as SF6 has similar properties in adsorption capacity of carbon dioxide. Right, so as both of them are greenhouse gases, and from this finding, an isotherm would be selected. And once the isotherm is confirmed for such a dual site Langmuir, so we can calculate the quantity absorbed as the figure shown, which act as the SF6 carbon, SF6 capture performance, and then we can create a breakthrough curves, which the proposed methodology would be explained after this. Alright. Alright, so for the methodology, right, so the proposed methodology is the first one we would do the assumptions. Alright, so as of now we have two assumptions, which we will not be considering energy balance, and also we will only take into consideration of only two components. Alright, so for the second step, we would simplify the mathematical breakthrough curves equation. Alright, and after that, we will obtain the gas adsorption isotherm for two different gases in a single adsorbent. Alright, so for the first step, we will construct the breakthrough curves, and then we will compare the curves with the literature study. And we will be using MATLAB as a software for the simulation of the breakthrough curves. Alright, so now these are the way forward for FYP project. Alright, so as you can see from the Gantt chart of FYP 1, we have several activities to be done during the FYP 1 semester, which are FYP briefing, several meetings with a supervisor, reading the articles, progress report, progress assessment, video submission and Q&A session, and also the interim report submission. Alright, so all this activity will be conducted from week 1 until week 12. And as of now, from the milestone, we have finished our FIP briefing. And the meeting with a supervisor have been conducted consecutively every week. Alright, so for the reading articles and the progress report, we will be doing it simultaneously because as we were writing the report, we would continue to seek for the support from the articles to support our data. And all the progress assessment will be done in week 6 and also week 9. And the interim report shall be done by week 11. Alright, and this is also the for the next semester for the FYP2, as we have list down our proposed methodology before. So these are the rough idea for our FYP2 activities. Alright, for the first 2 weeks we will select the isotherm and we will develop the breakthrough curves, and during that time we will also verify the curves simulated with the literature review, and during that time, during the development of the breakthrough curves and so the verification of the literature review, we will simultaneously do our writing with the progress report. Alright, and by the time all of these activities have been done, we will finalize the reports. We will finalize the report and submit them and conduct the viva session. Alright, so as of now, there will be no conclusion as this is FYP1. So now these are the list of reference that we are doing for FYP1 as of now. So I think that is all for my presentation today. Thank you.